Welcome. In a world where information just pours over us,
Yeah.
like constantly, the real superpower isn't just knowing stuff, it's connecting it all,
Yeah, sure.
seeing how it fits into a larger design. But what if that very idea of a larger design or scope, what if it isn't as simple as it sounds?
It's fascinating, isn't it? Because what one field calls the big picture, another might describe as global scope.
Right.
And yet another might see it as a really crucial sort of nuanced technical detail. The terms themselves, they actually carry vastly different weights and meanings depending on the context.
So today, we're taking a deep dive into exactly that, this multi-layered concept of scope and the big picture. We've pulled together some really insightful sources.
Yeah, everything from articles on strategic thinking in business to deep dives into computer programming languages and even some, real-world experiences from learners just like you.
Our mission for this deep dive really is to unpack these different interpretations.
Mm.
We want you to walk away not just knowing what these terms mean in different areas.
But crucially, understanding why those distinctions matter. We'll show you how a concept like global scope can be, well, a really powerful tool in one area,
Right.
and then something called a delicate API that you really need to handle with care in another.
So yeah, hopefully we can broaden your perspective on this surprisingly rich topic,
Yeah.
maybe offer some clear insights along the way. Let's unpack this.
Okay.
Okay, so let's kick things off with the big picture in, say, business and strategy. When leaders talk about big picture thinking, what are they actually getting at?
Well, it's essentially about strategic foresight. It's about crafting a vision for future opportunities.
Right, not just reacting.
Exactly. And it's not just wishful thinking. It's got to be this blend of pragmatism and, well, optimism, always kind of scanning the horizon for upside, for possibility.
Okay.
But, and this is crucial, it also means intentionally making space for reflection. Businesses need to acknowledge that even their best plans can get completely upended.
Yeah, like by external factors, a pandemic, markets going crazy, political stuff.
Precisely. And this ability to look beyond the immediate tactical moves is what keeps organizations truly agile. Especially when you hear that, nearly half of people feel unable to plan for their own future.
Yeah.
Businesses need that foresight.
So this big picture thinking, it sounds absolutely vital then for just staying healthy as an organization. What are the core benefits you see it bringing, especially when things get unpredictable?
Oh, absolutely vital. And it's more than just resilience, just bouncing back. It actively transforms companies.
How so?
Well, it's not just about spotting threats. It's about proactively kind of sculpting the future. It fosters an environment where innovation isn't some add-on, but it's baked into how they respond to change.
Okay.
And that directly impacts everything from agility, like we said, to the bottom line overall performance. It also seriously boosts their capacity for strategic foresight, that ability to look ahead, maybe even predict what's coming.
There's a great example of this from the early days of the pandemic. It involved an HR director, Lucy, at a tech company. Her initial plan, like a lot of companies then, was basically, okay, everyone back to the office.
Right, that was the default for many. But Lucy was clearly a keen observer. She kept up with the industry research.
It was showing.
Well, overwhelmingly, employees preferred working from home. And importantly, something like 83% of employers were actually seeing success with remote work.
Wow, 83%.
Yeah. And then you add the whole Great Resignation starting to bubble up. Lucy realized, okay, forcing people back, that could be disastrous for keeping our talent. So she did a complete pivot.
A pivot to what?
Her revised approach was really employee-centric, allowing choice in where and how people worked, putting serious investment into professional development,
Okay.
and bringing in innovative ideas like virtual team activities, offsites, but also dedicated in-office connection days for those who wanted them.
That really shows that future-minded leadership, doesn't it?
Yeah.
Not just reacting to the disruption, but actually using it to shape a better path forward by seeing that, well, bigger picture of the workforce.
Exactly. And that kind of high-level foundational thinking, it has a really direct parallel in software development, specifically with software architecture.
Ah, okay. So how does that connect?
Think of software architecture as the big picture blueprint for a software system. It lays out the main components, how they connect, how they interact. It's not about the nitty-gritty code yet.
Gotcha. It's the overall structure.
Right. It's about ensuring the whole thing is scalable, secure, performs well, things like that.
So architecture focuses on those broad characteristics.
Yeah.
Modularity, scalability, security, performance, reliability, flexibility, that kind of thing.
Precisely. And then In contrast, you have software design. That's where you dive into the detailed implementation of the individual pieces.
So they work together.
Absolutely, hand in glove. Architecture sets the framework, like maybe deciding on a microservices approach for an e-commerce site. And then the design fills in the details, like the specific database schema for the user management part of that system.
Right. And I guess sometimes the design details could even push back on the architecture.
For sure. A design challenge, like maybe a performance bottleneck showing up in testing, could definitely feedback and prompt an architectural change. Like, okay, we need to add a caching layer here.
Interesting.
And if we stretch this idea, this blueprint idea, to the business world again, the term global scope takes on another meaning entirely.
Okay.
Take GlobalScope Partners. This isn't just one company. It's an international network. I think 55 independent corporate finance and advisory firms formed way back in 1987.
Wow. Okay, so a network with global scope.
Exactly. And their strength isn't just the individual firms, it's how they operate collectively with that global scope. Their core values, things like openness, camaraderie, relentless entrepreneurialism, that allows them powerful access to investors across global markets.
Yeah.
And they aim for consistent, high-quality service everywhere. It's like a coordinated international strategy.
Sort of like a well-architected system, but for business deals across borders. Each part knows its role in the larger plan.
You got it. A cohesive strategy for success, operating within a larger defined framework.
Okay, that concept of a coordinated global scope for business, it finds a really fascinating but very different parallel in computer science, right? Where scope is maybe even more fundamental.
Oh, absolutely fundamental. In programming, scope is all about where a name, like a variable name or a function name, is actually recognized and can be used in your code.
It dictates visibility.
Exactly. And the beauty of it is that it prevents name collisions. You can reuse the same name, say count, for different things as long as they live in separate scopes.
Which leads us to a really key distinction, doesn't it? Between lexical scope and dynamic scope.
Yes, this is fundamental, and most modern languages lean one way. With lexical scope, which you also hear called static scope, the visibility of a name depends entirely on where you wrote it, where it's defined in the source code.
So it's fixed before the program runs.
Right, determined at compile time, usually. It's how JavaScript, Python, Java, most languages you use today work.
Okay. And dynamic scope.
Dynamic scope is different. Name resolution depends on the program's state when the name is actually encountered during execution. It depends on the call stack, the sequence of function calls that got you there.
Determined at runtime, then.
Exactly. It's less common now, but you find it in some older Lisp dialects, or interestingly, in shell languages like Bash.
Okay, maybe an example would help nail the difference. You mentioned Bash.
Sure, let's simplify a Bash example. Imagine you have a global variable, let's say x1. Then you have a function, call it g, that first prints the value of x and then sets x to 2.
Okay. Prints then changes x.
Now another function, f, creates its own local variable, also named x, setting it to 3. Then inside f, it calls our function g.
Right, so f has local x3, then calls g.
Okay, now if you execute f, remember Bash uses dynamic scope. When g runs, because f called it, it needs to find x. With dynamic scope, it looks up the call stack. Well, call me f did. Does f have a local x? Yes, it's 3.
Ah, so g uses f's x.
Correct. So g prints 3. And then when g executes x2, it's actually changing f's local x to 2.
Wow, okay. That's quite different. What if it were lexical scope?
If it were lexical scope, when g needed x, it would look at where g itself was defined, likely in the global scope in this simple case. It would ignore f's local x entirely.
So it would find the global x once.
Yes, it would print 1, and then x to 2 would change the global x to 2. Huge difference in behavior just based on that scope rule.
Yeah, no kidding.
Yeah.
Mastering those distinctions really does feel like learning the fundamental notes of programming, doesn't it?
Yeah.
I remember when I first started coding, getting my head around like local and global scopes. That was a real aha moment. It felt like a key step to actually seeing the bigger picture of how programs fit together.
Absolutely. And that analogy to learning music is spot on. You start with single notes, right? Then simple chords, maybe simple songs. Eventually, you get fluent. Those notes become second nature, and your focus shifts to the whole piece, the composition. Understanding scope is very much like getting those fundamental notes down. You need them before you can write symphonies of code.
Right. And these scopes, they come in different sizes, you could say.
Exactly. They vary hugely in their reach. At the widest end, you've got global scope. Think of it like a public square. Anything declared there is visible, accessible throughout the entire program.
Useful sometimes, but risky.
Yeah, useful for maybe top-level functions or classes sometimes, but generally considered, well, less than ideal for variables. Too easy to get name collisions, makes code less modular, harder to reason about.
Okay, so moving inwards from global.
You get things like module scope. This is common in languages like Python. Names are visible within a specific module, which might be one file or several, but not easily accessed from outside it. Good for information hiding.
And file scope, you mentioned that for C.
Right. File scope is specific to C and C++ec. Declarations at the top level of source file are visible throughout that whole file, that translation unit, but not automatically beyond it.
Got it. Then inside functions.
That's function scope. Variables declared inside a function are typically only accessible within that function. This is super common. It's like giving each function its own private workspace isolates things nicely.
Even tighter.
Block scope. This creates even smaller temporary environments. Inside an if statement, a for loop, even just a pair of curly braces sometimes, variables declared in a block are often only valid inside that block.
Which helps prevent errors.
Totally. Restricts a variable's relevance to exactly where it's needed. Modern JavaScript with let and const, C, C++, lots of languages use block scope extensively now.
And the absolute narrowest.
That would be expression scope, where a name is only valid for a single expression. Like the temporary variables you might use in a Python list comprehension, they exist just for that one line, then poof.
Okay, that makes sense. Now, you mentioned earlier something about a delicate API related to scope. You were talking about Kotlin's GlobalScope.
Ah, yes. GlobalScope in Kotlin coroutines. This is a specific implementation of a coroutine scope, but it's special because it's not bound to any particular job or lifecycle in your application.
Which makes it
Delicate, as the documentation calls it, it's incredibly easy to accidentally create resource leaks or memory leaks with it.
okay.
Coroutines launched in GlobalScope are kind of like background daemon threads. They just run. They don't keep your application alive if nothing else is running.
Okay.
And crucially, they aren't part of Kotlin's structured concurrency, meaning if they get stuck maybe waiting forever on a slow network call, nothing automatically cancels them. They just sit there consuming resources.
And if you launch many of them.
Yeah, repeated calls can just pile up more and more resource usage over time. It can lead to serious problems if you're not extremely careful.
So when would you use it?
Its legitimate uses are really limited, usually only for true top-level background processes that absolutely must stay active for the entire lifetime of the application, like maybe logging some background statistics or something.
And Kotlin makes you acknowledge the risk.
Yes, you actually have to use a special annotation at opt-in to even use GlobalScope. It's basically the language telling you, hey, be really sure you know what you're doing here because this can be dangerous.
Okay, wow. That's a very concrete example of scope having serious implications.
Uh-huh.
Let's dive even deeper into JavaScript now. It's everywhere, and understanding its scope rules, plus this related idea of closures, is pretty key for web developers especially.
Absolutely. In JavaScript, you primarily deal with three types of scope day to day.
Which are?
First, you still have global scope, just like we discussed, the widest scope, accessible from anywhere, convenient for simple things maybe, but risky in larger projects.
Risks like unintended changes, conflicts.
Exactly. Conflicts with other scripts makes code less modular. Best practice. Use it really sparingly. Avoid overwriting global things. Use descriptive names if you absolutely must use it.
Okay. Number 2.
Local scope, which in JavaScript is traditionally function scope. Variables declared inside a function, historically using var, are only accessible within that function. Think of it like a private room.
Good for isolation, reusability.
Definitely. Keeps different parts of your code from messing with each other's variables.
And the third type, this is newer, right?
Well, newer keywords enable it more explicitly. Block scope. This is like having nested boxes. Scope created within specific blocks as statements, for loops, while loops, even just blocks.
And this is where let and const come in?
Precisely. Variables declared with let and const have block scope. They are confined just to that block where they're defined. This offers really tight isolation.
Unlike var.
Right. var is famously function scoped, not block scoped, which can lead to some confusing behavior, especially with loops and asynchronous code. It's a major reason let and const are preferred now.
Okay. This also brings up variable shadowing, right, where you can have the same name in different scopes.
Yeah, exactly. If you declare a variable, say message, inside a function, and there's also a global variable named message, The inner one takes precedence within that function. It shadows the outer one.
It's not an error, just something to be aware of.
Correct. It's a feature of scoping, but you need to know what's happening.
So how does JavaScript figure out which variable to use when there might be multiple scopes involved?
That's where the scope chain comes in. You can visualize it like a stack of transparent sheets. Each sheet represents a scope, the current function scope on top, then the scope of the function that contains it, and so on, down to the global scope at the very bottom.
Okay, like a layers.
Exactly. When JavaScript needs to find a variable, it starts looking at the top sheet, the current scope. If it finds it, great. If not, it looks down to the next sheet in the stack and keeps going down the chain until it finds the variable or hits the bottom, global scope.
And this search follows the lexical structure.
Yes, crucially, it follows lexical scoping. The chain is determined by where functions are declared in your code, not where they are called from.
So an inner function always looks outwards to where it was written.
Correct. It accesses variables from its outer lexical environment, completely ignoring the scope of whatever function happened to call it. It's a very consistent rule.
This structure, this lexical environment thing, that leads us directly to closures, doesn't it?
It absolutely does. A closure is one of the most powerful concepts in JavaScript, built directly on lexical scoping.
So what is a closure in simple terms?
A closure is basically a function that remembers the environment, the scope in which it was created, even if that outer scope isn't active anymore, like if the outer function has already finished running.
Remembers its birthplace, kind of?
Yeah, that's a good way to put it. Think of it like a little backpack or maybe a lunchbox. The function carries around the variables it needs from the environment where it was packed. It makes the function self-contained.
That work mechanically.
It works because an inner function, declared inside an outer function, maintains a live link to the outer function's variables. Even after the outer function returns, if you still have a reference to that inner function, it can still access and even modify those outer variables.
Okay, that sounds powerful.
Yeah.
What are some practical uses?
Oh, loads. A classic one is data encapsulation or creating private variables. You can have an outer function create a variable like a count and then return inner functions, say increment and get count.
And only those inner functions can touch the count.
Exactly. The count variable itself isn't accessible from the outside, only through the methods provided by the closure. It hides the internal state.
Clever. What else?
Really useful for event handlers. Imagine setting up a button-click handler inside a loop. The handler function, being a closure, can remember which specific item or ID it was associated with when it was created, even though the loop finished long ago.
Right, so each button flick does the right thing.
Yep. And closures are fundamental to the module pattern in JavaScript. It's a way to structure your code, to hide internal implementation details, and only expose a public API, a set of functions or values you want others to use. Closures make that privacy possible.
So bringing this all together then, thinking about scope across different languages and paradigms, what are some core best practices for managing it effectively?
Well, number one, almost universally, minimize global variables. Just limit their use, only for things that are truly globally needed. It drastically cuts down on conflicts and makes your code easier to understand and maintain.
Okay, keep things local as much as possible.
Right. And in JavaScript specifically, always use strict mode. It helps catch errors, like accidentally creating global variables, and generally enforces cleaner code.
What about that shadowing thing? Avoid it.
Well, it's not inherently evil, but you should be thoughtful about variable shadowing. Sometimes just using clearer, more unique names across different scopes is better for readability than relying on shadowing. But other times, it's perfectly natural. Just be aware.
Makes sense.
And definitely embrace local and block scope. Use let and const in JavaScript. Keep variables contained within the functions or blocks where they're needed. It makes code so much more robust and easier to debug.
And finally,
Utilize closures where they make sense. Don't be afraid of them. They are an incredibly powerful tool, especially for that data encapsulation, privacy, and creating nice modular patterns.
okay. So we've covered a lot of ground here. What does this all mean, stepping back? We've seen how scope, or the big picture, morphs from, high-level business strategy
Right, for resilience and
and
agility.
to a really precise computer science definition about variable visibility.
Yeah, dictating exactly where a name works.
And even becoming this delicate API in Kotlin where you have to be super careful about leaks.
Exactly. And understanding these different scopes isn't just about, memorizing definitions for a test.
No.
It's about appreciating how context fundamentally changes what a term means and how you apply it. It's recognizing that the big picture for, say, a software architect is that high-level blueprint. While for a programmer deep in the code, the big picture might involve understanding how variables are interacting across different functions and modules because of scope rules.
So for you, the learner listening, this deep dive really shows that getting fascinated by concepts like local and global scopes, that is part of seeing the bigger picture in programming, and maybe even beyond.
Totally. It's about building up those fundamental notes, like we said, so you can eventually compose those complex symphonies, whether that's code or business strategy or something else entirely.
Which leaves us with a question, I think.
Yeah.
In a world where even these basic seeming concepts shift meaning so much across different fields, how might understanding these diverse scopes empower your critical thinking?
How can I help you when you encounter new information or tackle complex problems?
Right. To help you quickly identify, am I looking at a big macro strategic vision here? Or am I down in the weeds of a micro-level implementation detail?
That ability to gauge the scope of the information or the problem, that seems incredibly valuable.
We really hope this deep dive helps you navigate that vast ocean of information out there with a bit more clarity, maybe more purpose. Keep exploring, keep connecting those dots.
And keep discovering just how wonderfully complex and multifaceted knowledge can actually be.